Hey, welcome back to my bench. Today I want to do something a little different. I got a load of old test equipment and gear around my bench here, and I want to show some of it off. Some of the stuff I pick up throughout my years. I use it just for collecting. I don't actually use it for anything, but it does serve a purpose if it comes down to it. And I try to keep it in functioning condition when I get a piece. Either I'll repair it or calibrate it or do whatever to get it back to where it should be. But today I have an AVO, or AVO, I don't know how you pronounce it, but it's a multimeter. It's an AVO meter 8. It's probably 1974, I think. There's a sticker on the back. As you can see, it sits around, it's just dust. But let's take a good look at this and see what we got here in the case. First of all, the case itself is amazing. This is like 1/4 inch thick leather, and it's a rigid case, something you throw in the back of your van or truck and never worry about your meter getting damaged. It's pretty rugged. But this one's seen an easy life. It's not beat up at all. It's just dirty. A little bit of scuffs on it here and there, and it probably came with a shoulder strap, but that's missing. It comes with a handle, but I think this one's had an easy life. It looks pretty clean. But let's see what's in the case here. We have leads, nice thick leads. These are, I'm guessing they're like almost 1/4 inch thick, with these special end caps that will insulate. Because this meter is capable of reading up to 3 kilovolts. So you got to have leads that will do 3 kilovolts without killing the person. So these are connectors Mark II, connector Mark II, and they come with an end like this, and you have different interchangeable ends. So this is a ground clip that goes, and they also come with the harpoon style, the hook ends, and so that's your leads basically. And in the box we also have look at this, Ever-Ready battery SP2 for a longer life, made in Britain. I don't see a date code on here anyway. That's pretty old stuff. And then, this would be for your DC ohm resistance readings. So this battery would work on your ×1 and ×100 scale. And then we have for the ×10,000 scale, we have a 15 volt battery. It's kind of an unusual thing. It's just like it looks like a 9 volt, but it's a little shorter. And believe it or not, that's 15 volts there. So let's test these two batteries to make sure they're going to work for us before we try mounting the meter. What we got here on this one? Look at that, we got 1.5 volts on that old thing. I'm surprised that's not leaking. And okay, positive, negative. What do we got here on this? Oh, this one's up around 15.5 volts. So they're both pretty good. We're going to put them in and try it out. Let's have a look at the meter itself. Get rid of the case. So it's got a nice big linear scale on here, and it's intended to be used horizontally like this. So when you lay it horizontally, you can zero it with the screw, and you can get the needle bang on with the mirror in the behind, and you can get it right on. It's got different scales, DC amperes, 100 milliamps, 1 amp, 10 amp scale. It's got DC milliamps, 10 milliamps, 1 milliamp, 0.3 milliamps, and we're measuring down to 50 microamps on this scale. DC volts: 3, 10, 30, 100, 300, 600, 1000. But this has a capability of reading up to 3 kilovolts. So you would use this input for scales up to 1000 volts, and then if you want to go beyond 1000 volts, you would switch your lead to this one, and it's probably got a special insulation in there for it, and it would be its own set of resistors, and it would bring that the rest of the scale. And that'd be 3 kilovolts DC, 3 kilovolts AC. Here we got 3 ohm scales, times 1, times 100, and times 10,000. And AC amperes, 10 milliamps, 100 milliamps, 1 amp, and 10 amps, the scale for that. And then we have AC volts, which goes from 3, 10, 30, 100, 300, 600, 1000. So it's a pretty capable unit. It can do a lot for a multimeter. It has some pretty good ranges. It's got 3 separate adjustments for your 3 separate ohm scale, so that's kind of a nice feature too, and I'll get to why that is. This switch here, I believe this reverses your leads, and then I think it's a cutout here. I think it's like a circuit breaker. I'm not sure about that, but we'll figure that out. It's got a serial number and a date. Looks like it's 1974. I don't know why that's there. And then on the back we have abbreviated instructions, which is pretty good if you've never used one of these before. I'll hold this up, maybe you can read it. Get some proper light on there. No, if you want to pause that and read it, I don't know if you can. It might be too small. You have your battery cover. And we have an area for both batteries. They're marked positive, negative, and positive, negative. Okay, so we're live. There's a 1 amp fuse that I think it goes on the scale up to 1 amp. Beyond 1 amp the fuse blows. I'm not quite sure how it works on the 10 amp scale with a 1 amp fuse, so it probably tells me here if I took the time to read it. It comes with a spare fuse, and it says these are standard 1 amp precision fuse. So there you go. Have you ever seen a precision fuse before? That's what it looks like. So we got the batteries in. Let's try it out and see if we can get any readings out of this thing. So with the batteries in, first thing to do is set it for the ohm scale. Try the low scale first. Get these leads out. One thing is this: both of these red terminals are cracked. I think that's just from age. And I think the plastic shrinks over time, and it just cracked, and it's a little bit of an insulator there. Problem is, when you put this cup on top and pull it off, it pulls the insulator off too. So I might have to re-glue these back on. But just for this test, we're not going to worry about it. Okay, so on the 1 scale, our battery is dead. It won't even make it to the end, so we're going to have to get a new battery. Just stand by. Okay, so I replaced the D cell, and it's working properly now. Got it on the ×1 scale. This is set for ohms. So what you do is you short your leads together and let it go full scale, and you zero it with this. Zero's on the right hand side, and you zero it like that. 0 ohms. and that eliminates any lead resistance. Here's a 10 ohm resistor. And it reads approximately 12. Let me see what this thing reads on my other one. Ten ohm resistor that reads 12. So I got a 10.8. So it's out quite a bit. Let's try another resistor here. I got a 100 ohm. This one's at 5%. Hundred ohm reads about 95 on this scale. Let's try it on this one. Yeah, we got about 101. So we got a 1K resistor here. This scale is going to need to go up. We're going to go up one scale, and we're going to re-zero it because we're using a different pot this time. So zero it on this. So maybe the pot's a little dirty. Okay. 1K ohm. And it reads probably 950 or so. Let's see what it is here. No, bang on. So the nice thing about having 3 different zero adjustments is when you switch between ranges, you don't have to readjust it every time. If you only had one knob, you would have to, every time you switch to a different range, you'd have to readjust it. But with this, you can set them up and leave them alone. And you would just test it every time before you do your measurement. And to make sure it's still good. See, that one drifted now. But you get the idea. DC volts. We'll switch this to DC. And then we can go on this side. And we can start measuring voltage. So let's get a power supply going here. In case you're wondering, it's got this selection here for off. I'll show you what that's for. It's for when you're not using the meter and you want to transport it, you put it in off. And I'll demonstrate what it does. For example, if I left it in the DC amps scale and the meter's traveling around, see how the meter's bouncing? And when I turn it to off, it dampens that. And how that dampens that is it puts a direct short across the meter movement, and the meter movement acts like a little generator. If it moves, it's going to create a little electro force, and if you short that out, then it dampens that force, and it makes the meter more for transport, better for transport. So I got it on 30 volt scale. My power supply is feeding at 3.57. Just adjust this, trim this a bit, make it a whole number. Four volts, close enough. And we're reading on our scale. We're using the bottom scale, the 0 to 3, because I'm on 30. And I go count up 1, 2, 3, 3 volts. Let's try it on this scale. DC volts 10. And it takes me right up to 4, just before 4. Turn this down to about 3 volts. And we'll try the lowest scale. Well, we got a dodgy connection here. Okay. Let's go here, up to 10. We're at 9, 9.1. It's pretty much close. On the 0 to 3, we're up at 9. So it's not doing too bad. Let's turn this up some more. .5, and we're pretty accurate. Except it's got a dodgy connection here. So yeah, that's pretty much it. An old volt ohm meter from the 70s, still useful. Would I use it today? Probably not, because it's pretty big, pretty clunky, and it's got some dodgy connections. So, but this is how we did it back in the day. I have to glue that. Yeah, nice piece of gear. I'm looking here, it's even got the factory seals, still sealed. I think those are just rubber. Yeah, they're pressed in rubber. You can actually pull those out if you have a little piece of wire. But yeah, it's a nice unit. If you come across gear like this, I don't know, if you're into collecting it, pick it up. Be good to have on your bench for a second or third meter. Sometimes you need multiple meters, so it's good to have something like this, especially for reading up to 3 kilovolts. It's a nice handy thing to have for that. Alright, thanks for watching.